Welcome, everyone, to today's Explainer. We are going to explore a truly fascinating curriculum that perfectly marries analytical math with philosophical wisdom. Today, we're unpacking a lesson from the HeroesmartAcademy that shows how finding patterns in mathematics brings incredible clarity and order to our world. We're going to learn how to literally read the story hidden within numbers, specifically looking at the concept of slope, and then we'll see how this curriculum ties those math principles directly to real-life moral choices. It's a brilliantly unique framework, so let's just dive right in. Interestingly, the curriculum anchors its mathematical lessons in a biblical concept. It uses Habakkuk 2:2, which reads, "Write the vision and make it plain on tablets, that he may run who reads it." The idea here is that when we plot a graph or read a data table, we are literally making it plain. We take abstract, sometimes chaotic information and organize it. By making data visually clear, the curriculum suggests we empower ourselves and others to run, which means moving forward with real wisdom, clarity, and purpose. Here is our roadmap for today. First, seeing patterns and meaning. Second, finding slope from tables. Third, finding slope on graphs. Fourth, a quick practice session together. And finally, number 5, the curriculum's philosophy on education, morality, and peace. All right, section 1, seeing patterns and meaning and why recognizing change actually matters. In a world full of constantly changing variables, recognizing patterns is basically how we make sense of our environment. The source material emphasizes that spotting these patterns honors a desire for clarity and order rather than just living in confusion. So the big idea here is that slope isn't just some boring math formula you memorize for a test. It's a powerful tool that shows relationships. Whether you're tracking your school grades over a semester or maybe analyzing the financial growth of a new business, learning to find the slope allows you to see the hidden story in the data. And once you can see that story, well, you become a highly informed decision maker. By understanding slope, you take all that chaotic, changing information and turn it into a crystal clear, understandable relationship. Think of slope simply as the visual and mathematical representation of how one variable changes in relationship to another. If one thing goes up, does the other thing go up? Does it go down? How fast? That, in a nutshell, is the essence of slope. Moving right along to section 2, finding slope from tables and calculating the rate of change. So how do we actually calculate this rate of change when we're just staring at a grid of numbers? Well, to find the slope in a table, your first rule of thumb is to ensure the x values are increasing at a constant rate. Once you've confirmed that, you just follow 3 super logical steps. First, find the change in your y values. Second, find the change in your x values. And third, simply divide that change in y by the change in x. It is a straightforward, foolproof formula. Change in y divided by change in x. This data perfectly illustrates those steps. Let's look at the x column. We have 1, then 2, then 3. As x goes down the column, it's going up by exactly 1 each time. That is our change in x. Now, checking the y column, 3, then 6, then 9. As we move down, y goes up by 3 each time. By dividing our change in y, which we determined as 3, by our change in x, which is 1, we get a crisp, clean slope of exactly 3. That means for every single step x takes forward, y leaps forward by 3. It's perfectly plain and perfectly ordered, kind of like walking up a steady, predictable staircase. Okay, section 3, finding slope on graphs, also known as rising and running. Now we get to take those numbers and turn them into a visual line that tells our story at a single glance. When viewing a line on a graph, we use the famous rise over run method. You start by picking 2 clear, easy-to-read points on the line. Then you simply count how far the line travels vertically. That's your rise. Next, you count how far it travels horizontally. That's your run. Finally, just like we did with the table, you divide the rise over the run. Let's extract the journey from the starting point to the destination using some coordinates. Let's say our first point on the graph is right at the origin, 0, 0. Our second point is at 4 on the x-axis and 2 on the y-axis. To get from point A to point B, we have to travel up 2 spaces, so our rise is 2. Then we travel to the right 4 spaces, so our run is 4. We take our rise of 2, divide it by our run of 4, and boom, we establish a positive slope of 0.5, or 1/2. This means the value is definitely growing, but it's growing at a much more gradual pace than our first example. But watch out, because not everything goes up. If a line goes down from left to right, your rise is actually going to be negative. For example, say point A is up high at 2,5 and point B is down low at 4,1. To get from A to B, we don't rise up, we fall down from 5 to 1. That's a drop of 4, making our rise a negative 4. We still run horizontally by 2. Taking our negative rise of negative 4 and dividing it by a positive run of 2 gives us a negative slope of negative 2. The relationship here shows that as one variable moves forward, the other is steadily decreasing. It's a downward trend made perfectly visible. All right, section 4, let's practice together and test your understanding. You have the tools. Let's put this into action with a few rapid-fire questions from the curriculum. First up, checking the x values. 0, 1, 2. They're increasing by 1. Now checking the y values. 2, 5, 8. Look closely at how much y changes compared to x. What number do you get when you divide that change? If you saw a jump of 3 in the y values, you are right on track. Question 2. Visualize these 2 points on a grid. You start at 1, 1 and travel to 3, 5. Remember to calculate your rise over your run. You're going up from a y of 1 to a y of 5 and running from an x of 1 to an x of 3. Just divide that rise by that run. Question 3 is a really great test of what we just learned. You're starting high on the y-axis at 4 and ending way down on the x-axis at 0. Pay careful attention to the direction this line is traveling. Is the rise positive or is it negative? If you remember our warning about falling lines, you already know this one is going to have a negative slope. Now, question 4. Don't let this one trick you. Always check the jumps between both the x and y values before you divide. The x values are 3, 5, 7. They are jumping by 2, not 1. The y values are 9, 15, 21, jumping by 6. Divide that change in y by the change in x to find your true slope. And our final practice question. Visualize the grid, count the rise from a y of 3 to a y of 7. Then count the run from an x of 2 to an x of 6. Divide them and lock in your final answer. It is incredibly satisfying when you realize you can literally decode any line or table just by applying simple logic. But how does this logic actually apply to real life? Which brings us to section 5, Education, Morality, and Peace, the heroesmartacademy philosophy. Here is where the curriculum takes a really fascinating turn. It argues that education alone just isn't enough. The source material presents a stark warning. Education without morality simply leads to smart, supposedly educated people continuing to make bad choices that hurt themselves and others. It essentially asks, what's the point of being mathematically brilliant if you use that intelligence poorly? The curriculum then contrasts this with having a spiritual mind. Drawing from Romans 8:6-7, the course creators state that combining what we learn with a spiritual, moral mindset is their defined path to achieving true peace of mind. This all builds to a highly compelling final takeaway. The curriculum challenges its students to ask, how will you use this education? It proposes that true clarity isn't just about reading data, but reading it with a strong moral compass. Thank you for joining me in this explainer today. It leaves us with a pretty provocative question to chew on. In our heavily data-driven world, is mathematical literacy enough on its own? Or does true progress actually require a philosophical anchor?